Okay, so today's question is grid game 2017. We are given a zero index 2D thick grid of size 2 cross n, and we basically have to traverse from 0 to 0 till the end. And we have two robots. The first robot wants to minimize the number of points collected by the second robot, right? And the second robot wants to collect the maximum number of points. And we have to basically return if both of them play optimally, which what's the lowest number of points that can be collected by the second robot, right? There's this one important thing in this question that if you maximize the score for first robot, that doesn't necessarily mean that the second robot will score minimum. Like there was one test case there. So if you had attempted this question and you had a similar thought process, you will see that test case. I couldn't produce a smaller test variant of that test case, but I think it's not very it's very subtle, but it's an important thing. So we don't need to maximize the score of first robot. First robot can play, you know, less optimally if he wants to sabotage B. So the idea is how can B uh, what the path B can take, right? Because A is gonna play first, so B has very certain limitations on the path it can take. So A can go right, it can go down, and then it can go right, right? It can make this zigzag kind of path. A, it can make any of these paths. But for B, if you notice carefully, B can only either go all the way top and then go bottom, or it could go it could go bottom then all the way right. So these two are the things. And why is that the case? By the way, this is the test case that will fail for suboptimum if basically you try to maximize A's path. So let me show why this is the case, this thing for B. Let me take this example 852, right? So let's say A goes this, it goes down, then it goes right, right? So my path is essentially this. So you'll notice one of those areas is completely zero, right? Even let's say, let me just take some random numbers. Uh, A, B, C, D, E. Uh, Let me take M, N, O, P, Q. Let's say A takes some arbitrary path like this. So the path will look like MN 0, 0, 0, and D and E. Now, in such cases, B cannot go from bottom to top, right? It can only go from top to bottom. So either it will have to consume the bottom row or it will have to consume the top row. It has no other choices. So essentially, the paths B can take is very limited. It either has to go all the way bottom or all the way top, right? Even if you like remove this, you make this, let's say 0, 0, again, uh, basically you're traversing only the bottom. Then again, B only has this one choice. Other choice is just 0. So essentially what we can do is, first of all, we need a quick way to find what's the distance. Like what is the sum of this? What is the sum of this? So the first thing that comes to mind is prefix sum. So we're gonna make two prefixes. First of all, I want this to be 0 dot size, right? I want prefix 1 of size n. Actually, let me just use vector. Long long, right? The size, this is prefix 1. The size will be n, and all the elements will be initialized to 0. Similarly, I'll have a prefix 2. Now I'll have to initialize them. Prefix 1, the first element will be grid 0, 0, and the second element I want to initialize as grid1 0. Okay, so basically I'm making a prefix of the first and second row. Now I'll just initialize the cumulative sum I plus plus, and yeah, let me do prefix 1 I equals to prefix 1 I minus 1 plus grid 0 1 0 I. Similarly here for prefix 2, here I'll do grid 1. So I have the prefix array ready. Let me initialize answer, and what I'm going to do is I'm gonna loop from 1 to end of grid. This is basically n. Now I want to calculate the the maximum score A can score, right? So the maximum score A can score is for this let's say this I am transitioning, I'm going from top to bottom. So here the maximum score will be sum of this plus sum of this. If I'm transitioning from one, it will be the sum of this and sum of this, right? So let me first find the top sum. Top sum is actually easy to find. It should be just prefix 1 I, right? And then the bottom sum. Bottom sum will be prefix 2 n minus 1 minus I. Okay. But I'll also have to subtract it. If my I is greater than 0, then I'm gonna basically, actually this will be this only, and bottom prefix to I, right? Yeah, so if I am cutting from this, I want to exclude this first element. If I'm cutting from I equals to 1, so I will just remove, actually minus 1. Okay, so that is, so this will be the score of bot A. Right. We don't need to maximize this guy. We need to minimize robot 2 score. So let's calculate robot 2 score, right? This will be long. And since I'm minimizing the answer, this should be a big number. Now, robot 2 score will be, as I saw, the pattern will either be this or this. So it's going to be basically STD max of the top score it can get and the bottom, the best top sum score it can get. So for top now, its score will be basically prefix I minus 1, sorry, n minus 1 minus top sum. So whatever A scored, it can only score this much. And for bottom, what it can do is prefix, this will be 1, this will be prefix 2, n minus 1 minus bottom sum. So that will be the maximum of those two, not the summation, because it can only either go there or there, right? Then I want answer to be minimum of answer and robot 2 score. This is actually not important. We can just ignore and we can just return answer. So something like this should work. Let me try run that. Yeah. So all test cases pass. Let me try submitting it. Uh, there's a overflow. So basically, let me define what's the this int is grid only, no? Okay, I just need to make this a bigger number. I can make it 17, I think. To yeah, 10 to the power 17 should be there. Let me just use that test case. Yeah, oh, okay. Okay, cool. Awesome. So yeah, so just one pitfall, this thing. You can also just try and simulate, right? You can just uh see out robot 1 score, robot 2 score, and just compare for all these test cases, like mm, right. So yeah, just a, a quick pitfall there was, but overall nice question. This was a good medium question. Okay.